Hello. So here is our last example from topic 7.7. And in this example, we're going to practice these special cases, but with one additional step. This additional step is called factoring out the greatest common factor. And what that's going to allow us to do is to simplify the current problem into one of these special cases. But the first step is factoring out the greatest common factor. We know that when we're looking at greatest common factors and when we're trying to factor out, these factors, they have to be in common in each term. So let's look at 3. What does 3x cubed y have in common with 12xy cubed? Well, we can see they both have an x term. They also both have a y term. What's different is how many x's and how many y's each term has. They also have something very unique when we start looking at the numbers, but I'll put that on hold for just a moment in case it does not stand out to you just like that. So we have, looking at 3, it's a prime number, and so 3 is equal to 3 times 1, cannot be factored anymore. And then we have, let's break apart the x piece, x times x times x, because we know that x times x times x is simply x cubed. Anytime we multiply with this something with the same base, we add the exponents. The understood exponent on each one of these x's is 1, and so x to the first power times x to the first power times x to the first power is x to the third power right here. And then we have y to the understood first power. So that's how we've broken apart that first term. The second term, we will do something very similar, but let's look at the 12. So now we want to talk about greatest common factors. Well, if 3 is the only factor of 3 besides 1, then, and we want greatest common factor, then we need to start thinking, recognizing patterns in our brain. Can 3 go into 12? Ignore the minus sign right now. We'll deal with it in a minute. But can 3 go into 12? Well, you're probably saying, yeah, it can go 3 times 4. Now, for the variable part, times x, because there's only one x, times y, times y, times y. So y times y times y equals y to the third. So now we're looking for, what do they both have in common? Well, they both have a 3. They both have an x. And they both have a y. This one has one y. This one happens to have 3 y's. This one has one x. This happens to have 3 x's. All right. So now what we're looking at is, what is that greatest common factor? Well, that greatest common factor is 3xy. 3xy. So we're going to factor it out. And when we say we're going to factor it out, it just means we're going to put it on the outside of the parentheses. What goes on the inside of the parentheses? On the inside of the parentheses is everything that's left. So on this first term, we have the 1 and we have 2 x's, x times x. That 1, when we write x squared, is understood, so we don't have to include it. But with the second term, this is a 4, and so we do need to include it. So we have 4 and then 2 y's. So that's y squared. And now we're going to come back up and get this subtraction sign and put it right there. So we have x squared minus 4y squared. Well, now you should be looking at, I know that 4 is a perfect square. I know that x squared is a perfect square. And I also know that y squared is a perfect square. So I have another situation where it's the difference of two squares because I don't have that middle term. So we can break this parentheses part alone down to be a squared minus b squared. So if a squared is equal to x squared, then a is simply the square root of both sides, and the square root of x squared is x. B squared is equal to 4y squared. To solve for b, take the square root of both sides. The square root of 4 is 2. The square root of y squared is y. And so your b is 2y. Now you can come back to that a squared minus b squared is equal to a plus b times a minus b model and plug in your a and your b. So you have x plus 2y, x minus 2y, but there's one very important thing that you need to always remember when you're factoring out. I took this piece out and put it up here just to make it easier to deal with just that piece. But I can't forget the piece that I factored out. Very important, very important, very important. Don't leave it alone. So we do want to separate it at first, but then bring it back together with the whole problem at the end. If we don't, we will definitely make a mistake. So this is why I always say, write your steps down and look over everything. Make sure you're not missing anything before you proceed to the next problem. So this does it for today. This is topic 7-7. I hope you enjoy the videos. If you have any questions, please let me know. Have a good day, guys. Bye.